familiarization. You probably already know all this stuff, so we won't spend a whole lot of time at it. But my question is, do any of you ever look at your polars for your glider? Um, what can you tell from those polars if you do look at them? Any ideas? Don't hesitate to speak up.
Okay, Tom, I think it gives you wing loading and airspeed and something else.
Well, okay. One of the things it gives you is minimum sink airspeed. It also gives you maximum L over D airspeed. And it'll give you one more, and that is speed to fly. Those are the main reasons we want to look at the glider, the polar glider. So, what does minimum sink airspeed mean to you all in terms of practical use? Anybody got an idea on that?
Well, that's you'd use that to extend your flight as much as possible.
Okay, so for the altitude you've got, you'll stay up the longest. How about maximum L over D?
Best distance with zero wind.
Okay, so for the altitude you got, best distance. All righty, so let's look at the curve. Horizontal axis is airspeed, and most curves are nautical miles, knots. And we know 1 knot equals 6,080 feet, which is about a 100 foot per minute. So if you look at the vertical axis, usually shows it in just a single number, but it is knots, and that equates to 100 feet per minute. So here's a generic polar. It's kind of similar to the ASK-21 if you look at the weights on it, and you can see our airspeed and our sink rate there. So minimum sink, if you draw a straight line that's tangent to your, in this case, the blue line, which is the maximum weight of the glider, it'll show you the sink rate of about 1.2 at an airspeed of about 39 knots. So that's 120 feet per minute sink rate. If we go over to minimum sink, max L over D, then we draw a line from the center of the axis to a tangent on the blue line, and my drawing is not quite accurate enough, but it shows about 49 knots. Now you can also look at and compute the glide angle. And here's two different speeds. We're flying not at either min sync or max L over D. We're actually slower than min sync in one case and much faster in the other. But one thing that's interesting about this is the angle is the same. So you compute a glide angle by dividing the speed by the sink rate. And in this case, for the minimum sink, we've got 38 knots divided by about 1.4 equals about 27 to 1. And if you look over here at the faster line where the line intersects here on the blue line, you'll see it's 72 knots. It's actually about the same glide slope or glide angle of 72 to 1, 27 to 1. So what is that telling you? It's telling you that if you fly slower or you fly faster in the same glide angle, the guy who's flying 38 knots is going to get to where he lands slower than the guy who flies at 72 knots, but they're both going to land in the exact same spot. So racing pilots always know that You always fly faster and not slower. Okay, conclusions. There's only one optimum speed for the flattest glide angle. And flying too fast or too slow is less efficient. And the reduction in the glide angle is the same when you're flying too slowly or flying too fast. Okay, lesson, better to fly fast. So next time we'll talk about some more things you can get through looking at the polars, and that is best speed for cruising through sinking air and then cruising through rising air, and also how to figure the effects of headwinds and tailwinds. Now, clearly you're not going to have polar up in the cockpit with you unless you're using a flight computer, and that gets all its information from a polar. And you can construct using the chart just kind of a little speeds to fly to put on your knee board, so you'll know what to do approximately in the air that you're in. So that's all I got on this right now. 49 days to start, so it's not going to be that much longer. Hang in there, guys.
Thanks for letting me join you.
Thank you.
Thanks again, Van, or